Hello, everyone. Thank you all so much for having me here. This is my first time doing any sort of public speaking, so I'm glad you people are the ones that are here with me tonight. And I hope you enjoy the journey I take you on. This will not be about my research at all, but I hope you'll see how it's relevant and informative, hopefully, as we go on. So to set the stage a little bit, you might be wondering, what gives this girl the right? And I think that's a very valid question. I'm talking about a topic that's unintelligible from the title for the most part, but sort of my story starts with these guys. So these are rhesus macaques. These are a population that I've worked with on many occasions in a sort of free-ranging setting. And this is sort of what a scenario looks like on this island full of monkeys. And I'm interested in what's going on here for sort of a couple of reasons. So on the one hand, we want to know what these animals are capable of. There's so much we don't know about our natural world. There's so much we don't know about the species that we share this planet with. So we want to know sort of what's going on inside of their head in as sort of uninvasive way as possible. And even from this picture, you can see there's kind of a lot going on. So we've got this old guy getting groomed. We have a couple babies who are being taken care of by their mothers. We have like kind of a high density of monkeys for the space that they're occupying. So some complex things going on here. But at the same time, this isn't the population that has developed the iPad that is sitting on my hips. So we want to know about monkeys for what they're capable of. But we also want to know what differs between us and them. So along our evolutionary journey, what did we develop as a species that's made it sort of the fact that we have the Kensington Club here tonight, and these other species don't? So it's sort of a two-pronged approach here. One, what can we learn about them for the sake of them, and what can we learn about them for the sake of us? So with that, I invite you all to sit back and imagine a planet.
Got it.
And not just any planet, a planet full of apes. But not just any apes, a planet full of non-human apes. So this is the future I would like you all to envision tonight. And if you're familiar with a certain set of very famous movies, you might be wondering, is this the future that we're hurtling towards? Is an ape-based apocalypse somewhere in our future? And this is the journey I will take you on tonight. So in order to start answering this question, I think we have to start at the beginning. So we have to start with the rise of the Planet of the Apes. And I'm going to take this absolutely ridiculous movie and extract from it what I can. So through the sort of lens of this awesome sci-fi, we will be sort of looking at what real apes are capable of in terms of their cognition, what they think, how they communicate with each other, their behavior, and then also some very real history of this field of comparative cognition that actually has a lot of surprising parallels to what goes on in this movie. So where does our story start? Our story starts with James Franco. And James Franco's character, Will, has the very noble goal of curing Alzheimer's. That could be sort of, on the one end, stopping the progression of the disease, on the other hand, reversing it entirely. And he gives us our first little bit of scientific information to work with. So James Franco creates a gene therapy virus, quote from the movie, which allows the brain to create its own cells in order to repair itself, and something they call neurogenesis. So this is what we're working with from 20th Century Fox, and this is what we'll be building on to start. So things are going well. So the trials on chimpanzees, something we do not do anymore, have begun. And there are some sort of promising results here. This is Bright Eyes. She's solving a task that in the movie they refer to as the Lucas Tower, also known as the Tower of Hanoi. So she's doing this sort of complex action planning sequence. She's doing these really fine-grained motor behaviors. She's being very efficient with her actions. Cool stuff, and things we don't expect chimps normally to do. So what's up? What's actually gone on in the brain of Bright Eyes that's produced this behavioral response that we see? And so for me, when I hear neurogenesis and no more information, what I think of is I think like they just kind of bumped up the neurons going on in the brain. Maybe not in a specific area, so maybe it doesn't have to do anything with memory or anything like that. There's just kind of more of it, and it's everywhere. Maybe there's some more white matter to go alongside of it. We just got like a bigger brain going on. So the question becomes, would this be enough to make a chimp's brain sort of human-like? And we'll ignore the fact that this happens overnight and doesn't instantaneously kill the chimp. But that's the movie magic, That's great. And so to get into sort of our first scientific reference of the night, I think there's sort of maybe a group of researchers in this field who would argue that, yes, this actually is enough. So these two researchers, Cantillon and Piantadosi, posed this perspective paper that says essentially we have a lot of these differences between us and the rest of the apes and us and the rest of the monkeys that look like sort of one of degree, like there's fundamental differences here. But maybe what happened is we just have massive brains and they don't. So compared to the chimpanzee, our brain is about 4 times bigger. And they say we can't just discount this huge increase in sort of size and computational power. So they just say, okay, we have these huge brains. We have a lot more capacity to process information. So on the one hand, we have this sort of like mega brain expanding meme. And then on the other hand, we also have language. So the ability to take something like a complex emotion and scrunch it down into a single word that then we can share with others easily, we can think about ourselves more easily, that also sort of expands our capacity to process really complex information in a really simple way. So they sort of argue that through this expansion that starts with bigger brains, we actually get these massive increases in cognition and performance that we see in tons of different tasks. So maybe James Franco had it right. But maybe not. So of course, there's plenty of other accounts for what's going on here. Everyone has a little sense of superiority of like the thing I study is the silver bullet. That's why we have iPads and they don't. But I'm just going to talk about one of those examples tonight. So in this paper by Herman et al. From the early 2000s, they said that, sure, we've got big brains. We can't discount that in our studies. But not all differences are created equal. Maybe what we are is generally more capable, but also specifically more capable in the social area. So what these authors did is they threw all of these tasks at a bunch of non-human apes and also 2.5-year-old children. And why 2.5-year-old children? Well, their brains are smaller, they're kind of dumb, but they're not that dumb. And so we have this sort of suite of tasks, this test battery as they called it, where everything in purple here is a physical task. So can you remember where I put something? Can you tell which quantity is bigger? And then everything in blue is a social task. So can you follow my gaze when I look this way? Do you understand the communicative cues that I'm giving you for the sake of maybe finding food or finding a toy, something like that? And so they took these great apes, 2.5-year-olds included, threw this all at them. And so here we see the results of all of those purple tasks, all the physical tasks. And we see that that's pretty good for a 2.5-year-old. They're getting it like 75% of the time. And importantly, so are these chimps and orangutans. But where things really start to look different is the social tasks. So by only 2.5, children are vastly outperforming adult great apes only in social tasks. So what this sort of tells us here is that, sure, maybe if you put a human adult versus a human chimp, you get some differences. But even when you even the playing field a little bit, where you start to see humans really shine is this sort of social question. So getting back to our neurogenesis question, I think by this account, maybe just sort of general bigger brains is not quite enough to do it. But let's move on. It clearly works, right? What happens next? Well, sad part, this movie did come out 15 years ago, so I'm sorry for the spoilers, but maybe this will inspire you to watch it. It happens pretty early. But Bright Eyes, the chimp you saw before, unfortunately, she escapes. She gets sort of aggressive with the people there, and she's killed. And this leads to the whole study being shut down. James Franco is devastated. This is his life's work that they've canned. But, in a surprising upside, they find that Bright Eyes has a baby, and that's who she had been defending. And so James Franco gets to become a father. So James Franco takes it upon himself, sort of from an egocentric perspective of not wanting his research to die, but also to raise this baby chimp in his home. He names him Caesar, by the way, so he gives him a name, he brings him home to his aging father, puts him in clothes, basically attempts to raise him as much like a child as possible. And so you might be asking, where did they get this idea? And the answer is the 70s. So in the 1970s, some really crazy, deeply unethical things happened in the primate cognition world. So pictured here is Nim Chimpsky. He was one of a set of chimps that was taken from their mothers and raised as close to a human child as possible. So they brought these animals into homes. They attempted to teach them ASL because chimpanzee vocal tracts aren't quite as fitted for speech as ours are. And they said if we sort of take the nature versus nurture debate and we give them all the same nurture as a child, can we make a human? And so this is a real-life photo of Nim and a very grainy photo of Caesar from the movie, because there's no sort of publicly available images of a 15-year-old movie online that I can work with. But there's a ton of sort of parallels between what Caesar does and what researchers attempted to do many, many decades ago. And sort of continuing along this vein of lack of ethics leading to problems, we see that the sort of next step is similar as well between these real-life chimps and Caesar in the movie. So Nim and others were very adorable as babies, very fun to have in the household, but adult chimpanzees are much, much stronger than humans are. So basically, by time they pass their like juvenile stage, they're too strong, sort of too volatile to have in the house. Basically what this meant is that all of these chimps were shipped off to like invasive research facilities, sanctuaries, I use quotes intentionally, and the sort of same thing happens to Caesar here. So they sort of follow what becomes Caesar's protagonist origin story, or villain if you're wrong story, is very much in line with what really happened to these animals. But in terms of a sort of bright side, what this does afford Caesar is the opportunity to communicate with members of other great ape species for the first time ever. So let's take a look at that. So this is Maurice. Awesome. So what do we see just there? So we know why Caesar's pretty good at ASL. He was raised by James Franco. He also was in utero while his mother was getting dosed with this brain-enhancing drug. But Maurice is like really good too, right? I mean, that's complex stuff going on. He has this like altruistic warning here, pretty good sentence structure, like good use of negation. This is really impressive, like referential to other things. So I'd just like to ask the audience, does anyone know the longest sentence produced by a non-human primate via ASL? I'd be happy to inform you then. It is, give orange me, give eat, orange me, eat orange, give me, eat orange, give me you. Which, like, it's not quite the same, right? Yeah, so you might be saying, like, okay, we did these horrible things to chimps, and then what we got out of it was give orange me, give eat orange me, eat orange, give me, eat orange, give me you. Like, is this all? And the answer is not quite. We did a little more than that. So I'd like to introduce you to another very real non-human primate. This is Kanzi. He was a bonobo. My friend who had the absolute honor of working with him before he passed away called him a chunky bald diva. And Kanzi is also really special and also has some cool parallels to Caesar in our story. So Kanzi, rather than being trained in ASL, was actually trained on this thing called a lexigram. So these are symbols here that correspond to sort of a vocal output. So if he presses 2, he hears the word 2, and he associates that with 2 of whatever quantity he's talking about. He also had a word for burrito, which he used a lot, hence why he lost some weight later in his life, but was a little round here. And Kanzi's sort of special story, in addition to being really skilled at this, was that he had a sort of Caesar-like upbringing where he wasn't exposed to a mystery drug in the womb, but it was his mom, actually, that was being trained on these lexicograms. And he just sort of passively picked it up as a baby who just happened to be in the testing room. And so what we see, maybe through this sort of adding symbols, information processing increase, is that Kanzi, in addition to being really, really skilled at using all of these symbols on the lexigram, started to do really good at a lot of other tasks as well. So we found that Kanzi could make stone tools. He could be taught to make stone tools in the way of like early human ancestors. If you compare this to Caesar's tool in the movie, it starts to look less impressive, but it's still cool, right? We also found that Kanzi, in a study published this year after he passed away, was able to arguably play pretend. So he could request a bottle of empty juice that had a pretend pour go on. So really sort of potentially very abstract thinking. We also did another one of these, like, let's throw a 2-year-old and a bonobo against each other and give them 600 sentences of instructions, things like that. And they performed basically equivalently. So this was a human speaking a sentence, asking him to do something that he could sort of comprehend and carry out. Getting back to the movie, one of the sort of not-so-spoilers, given this movie is called Rise of the Planet of the Apes, is that the apes rise. And so one of the questions I was asked by my friends as I was putting this sort of slideshow together is like, all right, but it's apes, but like, who's going to do it? Like, what do you think? And we sort of see these roles start to form that play out in these future Planet of the Apes movies where Maurice, the orangutan, he's the strategist. He's like calm, cool, and collected. We have Caesar, he's our chimpanzee, he's our leader. We have Buck, the gorilla, who's kind of the muscle of the whole ordeal. He like takes down a helicopter at one point in the movie. And then we have Koba, who's a bonobo, and he's kind of the troublemaker. He's an agitator that they're setting up for future cinematic conflicts. But like, so how are we doing on this? You know, with what we know about non-human primates, are these good roles? And I think for Maurice, the answer is yes. So a little bit about orangutans. This is a species that is semi-solitary. So that means that they don't live in big social groups like us or the other great apes do. So I don't think he'd want to really be in the limelight, but they can show themselves to be really cool, like social learners. Again, not as good as a 2.5-year-old, but still pretty impressive. So I think he's sort of well fit for this strategy role. I think Caesar is also right on the money. So we have far more chimps in the world than we do these other great apes, partially because they were used for research for so long. But they're also incredibly aggressive in the wild. So if you're an adult chimp, the probability of you dying is most likely going to be from another chimp. They have these lethal intergroup conflicts. They hunt, very territorial. So I think if you sort of had to pick this lineup, Caesar's also pretty good. Where it gets a little complicated is Buck here. So you guys might remember the meme of like 100 men versus a gorilla from the internet like last year. People were like, oh, who would win? And I think people wanted to know about the gorilla because they're huge, right? They have this physical intimidation. But what gorillas are more akin to is like a cow. So just like cows need to have multiple chambers of stomachs to break down all of the plant matter that they're eating. Gorillas kind of work the same. So they're what we call folivorous. They eat leaves literally all day because they don't have much calories. And what looks like a sort of super broad chest and abs is sort of just a lot of intestine that's just breaking down all this plants that they're eating day after day. So I think the physical intimidation and actual risk don't match up too much. And who I think they got super wrong is koba here. So koba is a bonobo, probably the least well-known of the great ape species. But what they're known for is, despite being very closely related to chimps, they have sort of almost opposite levels of aggression. So this is a matriarchal society, meaning that the females are the dominant sex. When they meet another group, the typical response is that everyone starts having sex rather than everyone kills each other. They've eliminated. I've seen it, yep. Yeah, San Diego Zoo if you guys are ever interested. And yeah, so I think it's sort of a miscalculation, especially for a group that's this species has basically eliminated infanticide in the wild. They've done these really cool things. And so to characterize koba as the agitator, I think is a little bit messed up. Even if they were to have done that, they probably should have made him a lady, because typically it's the dominant females that sort of aggress down towards the less dominant males. So some question marks there. But bringing it back in my last couple minutes, you might want to know where have we gone with this? What's our probability of an ape-initiated apocalypse? And I think the answer is approximately 0. You never know, but you kind of know. I think as we sort of discussed and explored tonight, there are really a large amount of differences just in things like absolute brain size and overall cognitive power between us and the other great apes that our couple years of divergence have led to. But I think there's sort of another question that thought that I want to leave you all with. And that's a pretty famous quote from the movie. So this is Apes Together Strong. You might be familiar with, might not. And so the question is is this true? Are these apes together strong or are they not? And I think the answer is not, unfortunately. So where I think I want to leave you all is that, sure, there's these big differences between us and non-human primates, but we really are special when it comes to this sort of social question. We infer each other's beliefs, our desires. We have all these rich representations of our friends' minds. We share things just because we want to, because it feels good. We help others, even if we're unrelated or don't know them, at cost to ourselves. And I think until our great ape relatives can achieve that, we won't have an apocalypse anytime soon. Thank you all so much.